Welcome to Joe and Mariana's podcast.
All right, we're back after a long time to cover one of the most epic texts of our time.
Absolutely. The Emperor of All Maladies by Siddhartha Mukherjee. Brilliant writer. Brilliant.
Whoa. I thought I was going to be the one praising this, this egghead trying to stir up, make me feel dumb.
Not at all. Not at all. I've just had a medical appointment today, and I mentioned it to the nurse that I talked to, and she said, "What's the name of it?" And I wrote, she wrote it down, and I said several times, even when he got into the nitty gritty of how, cancer cells replicate and how, that kind of business. I would stop reading and look up and say to myself, I can't believe I'm really understanding this, but I think I am. Mm-hmm. And it is his, the book, even though the subject of the book is cancer, it is so elegantly written that it is actually a pleasure to read. And so even though the subject matter is difficult and hard, and maybe something that a normal person would want to shy away from, the writing is so elegant that I found myself enjoying reading it. I don't think I will reread it, but I did enjoy it when I read it.
Well, now you're primed up to read his real, I think, book that put him on the more, popular map is The Gene, where he writes his second book about just what is DNA. Well,
that's a good idea, because I, over and over again, that's one question I continually have. Wait, now, can I visualize a gene? What is a gene? A gene, and so that I took, high school biology and a smattering of biology in college, but never with any kind of deep understanding or grasp. So yeah, I probably should read that to try and gain a better understanding.
Yeah, that's the one. The Gene is where I think PBS made a show about it like right away. He became more a TV star, I think, and so yeah, that one's really. I got to read that one again.
Well, PBS did a 3-part documentary of this book. And the executive producer was Ken Burns. He wasn't the main director or documentarian, but he was the executive producer in 3 parts, funded by every cancer organization that ever existed, I think. And he does, Dr. Mukherjee does speak during the documentary, but so do many, many, many other doctors. But he just has a way about him that is relaxed and just clear. Relaxed and clear. That's the best I can say.
So, this guy, I actually, when I see him talk, he has a beard. It kind of reminds me of maybe how like Abraham Lincoln would speak, maybe. Just kind of this like sad, but
yes,
all-knowing, but
yes,
still hardworking and optimistic-ish. Kind of timeless dude. And so he is, it's... Did I send you that article where it showed just pictures of his apartment with his his wife is an artist?
No.
And they have a really luxurious, but in not a bad way. It shows their Manhattan lifestyle. It's pretty cool.
Yeah, send that to me afterwards. So let's talk about it. So what did you learn? What stood out to you first as you started reading the book? What did you learn?
Well, let me start off with something that will elevate your conversational cred in any dialogue. You say, leukemia, which we all know is a cancer of the blood, but leukos is actually Greek for white. So, get that Greek out of the way. And oncology comes from the Greek word onkos, which means burden or a load, a heavy, some kind of heavy thing.
That's right.
And you didn't know, I casually, a little Greek here and there, that karkinos, which is the root of the word cancer, it means a crab. That's why that zodiac symbol, I guess, is a cancer, the whatever anglicized version. Because, this may be something you might be interested in. Cancer used to look like, when they would try to cut it out of people, a clutch of cells, or the tumor looked like just a clutch of cells embedded or entrenched in the tissue that looked like a crab trying to run away into the sand. It's very interesting. Greek, it's all, yeah.
Absolutely. Well, on that same note, if we look at Latin roots, scrofula, which is a disease that I would read about, I probably in Dickens, which I always thought was a skin disease, is not. It's tuberculosis that's characterized by a chain of swollen glands. It means piglet, and it looks like a bunch of piglets suckling, and that's why they called it scrofula.
Oh, that's interesting. I also read some Latin. Latin. You want to trade Latin words? Did you know that the radical, which of course in this text we read is a radical surgery. It sounds like something crazy or extreme, or actually comes from the Latin root, the Latin origin.
You blew the punchline.
I meant to say that. No, that was intentional. That was a clever play on words. The root of the Latin of the word radical comes from the Latin word root, or origin. What seems clumsy to the lay person is actually quite clever.
Oh, that was another deliberate use of the word clumsy.
Yeah, that was all intentional. But so Greek words everywhere. Listener, you can use that, and if someone is trying to put you in a corner of your own, lack of knowledge, you can throw some Greek at them, and it'll put them in their place.
Yes, and more commonly, more common than scrofula is influenza. Because they believe, because it was a cyclic disease, that it was derived from the influence of the stars. So they called it influenza. And one that sort of was interesting to me is the word typhoon, which I always thought was some sort of Japanese root, but no. Oh, no, it's Greek. And it is from Typhon, the god of wind.
Oh, well, speaking of stars, if you happen to casually look, coronavirus, the word corona comes from the Latin word for a crown, much like the sun's corona of solar activity happening there. So that's a double little lesson for you of corona. Yes, a little astronomy and biology, 2 for 1. Absolutely.
Aren't we smart?
All right, anyway, enough of that pontificating. But
that was important. But the fact that he included those definitions and origins of these words, which we're used to using, but we never maybe thought about why do they call cancer, is a way that he engages the reader, which is another way that he's so approachable in his writing. And so I really appreciated it because I love word origins anyway. And I just thought that was a way of connecting to the reader to make something that is big and mysterious and scary more, I can't think of any other word besides approachable to the common reader. That, these doctors in Greek day, in classical Greek days, were just reporting what they saw, what it looked like. And so they called it cancer, and so they called it scrofula. Yeah, it's just, I think it's a note and he deserves praise for that.
Yeah, if you could, it is crazy though. He could be just around somewhere. Like if he comes to San Francisco, you could just see this guy like speak, or it's pretty crazy.
Yeah, I think you should keep your antenna out for listening to him, because he is an expert and he's also easy to listen to. And you're right, he does have this kind of aura of a little bit of sadness about him, maybe not just seriousness, but kind of sadness, and a kind of, in California, we would say sort of laid back affect, but he's not a dude. He is very, very smart.
Well, his hair is pretty crazy. If he didn't have a suit or white coat on, he might look like just a random like Whole Foods shopper or something, like scooping nuts into a bag or whatever. Or Berkeley Bowl shopper. But
right.
So this has lots of different topics. It goes historical, it goes political, it goes what's the other
social
thing? Yes, social, statistical, all kinds of stuff. And so I got notes here, but I guess like one of the things that cancer is so crazy is that what I take away is that it is your own human cells where the DNA mutated spontaneously or from a carcinogen, from an outside thing, or from a virus. He talks about that too. There's different cases, but the thing they have in common is that your DNA gets mutated, and there's certain things that all the cells must do, which is they have to die at some point. They have to self-destruct, and some cells just don't do that. They live forever or live too long, and that mutation gets passed along, or the cell reproduces too quickly, like too frequently, that gets changed. So if we got too many,
right?
Or or he talks about a cell that lives in your stomach can just say, "Hey, I'm tired of stomach. I'm gonna go move to the brain," and it can just relocate. If it wants to. That's another crazy thing.
Yeah, some of those additional things. So let's look at his actual definition, that cancer results from mutation of cells that causes uncontrolled growth. It's a mutation that affects genes that incites unregulated growth. And along with that unregulated growth comes sometimes the ability to move, as you said, say from the stomach to the brain, other parts of the body. And when they got down to the nitty-gritty of what's going on in the cells, they observed, or they could find somehow, that whatever, they described it metaphorically as a stuck accelerator pedal, so that the growth just goes on continuously, as well as another mutation, there's no brake. And so normally the cell control system somehow controls the growth, but this double mutation of uninhibited growth, wild growth, no brake system to stop it, is sort of what happens with cancer.
Yeah, that's about. Yeah, it's so it's so crazy. It's the craziest thing you think of. He says stuff like, yeah, you might, and you got a cancer. It's multiplying too fast, but it's not fast enough to actually have a tumor that will interfere with whatever organ it's attached to. So you have, I guess that's a benign tumor. It's like, it's not, we don't think it's growing fast enough, and it's there, so maybe we just don't worry about it. But then when you get two mutations where you got growing too fast and like relocates, it's like, okay, well now it's now over here. And so it's almost can be like a combination of mutations where I wish I had that. He has a timeline of a guy working in a whatever, smoking every day. He gets a lung cancer. Doesn't really realize it though. It's just there. Then he, something else happens. And then that particular lung cancer like speeds up and now wants to move. So it's almost like you don't just catch it and now you got it. It's like you might have had it, but it's undetectable, or you had no symptom, and then something else triggers a mutation, and it might not even be another carcinogen, just a spontaneous mutation of that lung cancer, that it accelerates, it's interfering with your life. And then as you get older, it's, your organs get worn out anyway. So now it's like, oh, you got a bad cancer. It's like, well, maybe it's the regular one, but your organs are not as good anymore. So it's like hard to know which is the thing that's taking you out or making you ill.
Well, I think that the age factor has to do with, I think it has to do, they say that cancer is a disease of old cells. And I think I don't know if it's exactly the longer you live, the more mutations you suffer, or the longer you live, the weaker your genes become, like you said, and so that mutations occur. But knowing, I never thought of it, but you don't catch cancer. You have the potential for it inside you. And there has to be some insult, whether it's a virus or even an injury, I think, or even, a mutation, that whatever kind of insult it is that triggers all of this stuff and this accelerated growth, no breaks, and also along with it on these pathways, as he described, sometimes there is the ability to be mobile, to go to other parts of the body. So it's and then there's the hereditary factor, so that also, is another issue. It's very complicated. And what I learned in the historical aspect of the disease was that they kept looking for one cause for this cancer, a universal cure. They wanted the silver bullet. And there really isn't one. They have made lots of progress in some cancers and not as much progress in other cancers. Yet, all of those cancers still share that characteristic of unbridled growth. Mm-hmm. And so that's what makes them similar.
Yeah, it's also just mind-blowing how well, yeah, I'm a doctor. You did something. I didn't do anything. Come on. What, something? No, I don't know what it is. And then, or, oh yeah, you caught this. This is a virus. It's blah, blah. But, and then, yeah, there was that one character who swears it's a virus because he had an infected chicken, and then in the 20s or something, and then he could spread it to another chicken, and that people were like, that's not likely, but actually he was right. It was his particular one was a retrovirus, which actually can infect the cell, and usually a virus usually does want to infect your cell and take over the functions of the cell and reproduce itself, but doesn't really want to go after the nucleus, which is where the DNA is. But there's some retrovirus where, that is what I want. I do want to get in there and change the DNA.
Yeah. There was just no universal cure. There was no universal cause, and there was no universal cure.
Yeah. And so you got people arguing, you got different, it's just so varied that, and you're trying to work across history, look at old studies where this guy's doing this and his patient was this, his patient did, it's so many multiples away that it's just impossible to consolidate all this data. That is just crazy. Words, theory. Now I'm just saying things that seem to go with it.
Well, he did point out. So this was an interesting point that I was going to touch on today. He did point out that he did point out that scientists who were studying the causes of cancer, the pure research part, and doctors who were trying to cure cancer were not talking to each other. And so even at conferences, if they had breakthroughs on one side or the other, that knowledge didn't seem to get transferred very easily. And I think that is partly because of ego. This book is about cancer, And he does personify cancer, and I'm not very comfortable with that. But he also spends a lot of time on the heroes of cancer, the doctors, the scientists who made the breakthroughs. And so historically, it's a story of these men primarily who have either done the experimentation to look at the cause of cancer or look at some way of curing it. And a lot of the advancements seemed to depend on egos somewhat. And not only that, but also what the scientific community does seem to be swayed by what comes into fashion. And everybody seems to, jump on the brand new thing that seems to be a possibility. And so it's a lot about egos. It's a lot about what's in vogue. And of course, it's about money.
Yeah, it's all everything. Yeah,
it's everything. Yeah.
One thing about the you can't cut it out anymore. Like, you cut it out, it's going to come back because it's in the DNA. You've cut out the most recent children of the original multiplying cell, but it's just going to make more. And so then the chemotherapists started their war, where we got to give like this chemo, 4 types, 5 types, and it just obliterates your humanity.
And your good cells along with the bad cells. Yes, that's the problem. Practically, it's poison, so it practically would kill you.
And he makes the point how but then, so you've wiped out the ones that will die from it, but you've left behind the ones that survive it. So now the next generation, the next tumor that comes, will not work because it survived it already. Which then brings me to our old friend Jared Diamond about the humans who had the animals and would contract the animal mutation diseases, and it would wipe out people, but then the ones that survived were no longer would get better from whatever mutation of the flu. And so that's where pivot back to Mukherjee, Dr. Mukherjee, that cancer is kind of like humans, where we go to a location, figure it out, make the environment suit our needs, and then kind of exploit it, maybe to our own suffering, our own detriment. So he's like, we're exploiting the earth, taking what we can whenever we can, and our own cells are exploiting our own organs whenever they can. And even no matter how we fight it'll work a little bit, but then the next generation will resist it.
Yeah, because mutation is inevitable, and evolution is inevitable. So on this 3-part documentary, his final words were, just as cancer evolves, we have to evolve too, and that means evolve our treatment and understanding and our research, all those facets of understanding cancer. We have to evolve with cancer in our understanding.
And if I could just go back to that, what I just did there was, taking 2 separate academic texts and linking them together in real time. Anyway, what you were saying?
Bravo. Oh my gosh. I found, the interesting historical aspects of cancer that it was first written about, I guess, in like Egyptian times. And what was written about was breast cancer, of all things. I think that's kind of interesting. I suppose it was what they call palpable. You could touch it, so you could see it. And maybe that's why. But in the days of Hippocrates and Galen, I think Galen came slightly after Hippocrates. Galen is the one, and I never understood this entirely, but he decided that the human body is composed of 4 humors. He called them humors. And that cancer was caused by an abundance of black bile. And so that definition stood for 1,000 years. And then in the 1500s, Vesalius began doing autopsies, and he searched for the black bile, and guess what? Couldn't find it. And so only through actual raw research and, actually looking for but not finding what was supposed and only theoretical did they discover that these humors. So now humors are out, so the whole balance of humors and melancholy and color and all those things are out.
Mm-hmm.
And it surprised me that he focused so much on the blood cancers, leukemia, but I think part of it is because he is a leukemia specialist. And the fact that historically they couldn't do surgeries because there was no anesthesia, and any surgery would probably kill the patient. But in the 1800s, finally, Lister developed antiseptic. And so then they could do surgeries. And then they could do also in the earlier 1800s, they developed anesthesia. So then surgeries could be performed, and that's why surgery sort of was ahead in the horse race of treatment, I think.
Well, I was waiting for that lengthy talk to end so that I could go back to the humors, where you would have to bring things out of balance back into balance. Sounds quite Aristotelian, if I do say so myself. See,
okay, yes.
You see what I did there?
I'm sure.
I took another text from another podcast episode and linked it spontaneously.
I'm just in awe. Well, yeah. So that's why they used to bleed patients to get rid of the bad blood, to get the body back in balance. And so, I think that does date back to Aristotle. So, they're experimenting, and they're still experimenting. Medicine is not an exact science. It's just really pretty fascinating.
Yeah, my old roommate, who was my roommate in college, he was been feeling sick for a long time, and he has a type of cancer now, which is not leukemia. He has too much red blood cells, and they're making too much, and it actually makes him really tired. Like he's like fatigued like all the time, and all he can do, he has to go in and he has to get phlebotomy, like the blood is taken out because he's got too much.
Oh my gosh, yeah.
And but after this book, I wonder if that means he's vulnerable to, if he gets cut, he doesn't have enough platelets, or like there's not enough room for the platelets to clog or clot a cut, or does he have enough white blood cells? That's what I don't know.
I don't know either. Well, white blood cells fight infection, and I think the clotting mechanism is in the red blood cells, but I'm not certain about that. We need more research on that. He does mention, I think, that particular kind of cancer in addition to leukemia, but I don't remember the name of it. But he does talk about a question that I never considered, and that is that there was a disagreement and argument and debate at some point about what science should be doing. And so before like World War I, I suppose, science was its own end, and scientists did research wide open, just anything that appealed to them, just for the sake of the research, just for the sake of the knowledge and the science. However, once science became the object of science was use, and so then research had a goal, then it narrows the focus, right? And the most common usage of science was for war. That's how they developed chemotherapy from mustard gas from World War I.
Oh, is that right? Oh, I remember reading that part, and I couldn't link that to what does this have to do with anything.
Yeah, that they discovered what it would do to cells, and they decided to try it on cancer cells, and that then chemotherapy. And so then, chemotherapy becomes the baby of the scientists. And so that's what they're studying, and they're sure they can find one drug that can beat all cancers and cure it. But of course, that didn't work. That didn't work.
Mm.
And also the connection, he uses an awful lot of imagery that has to do with war and battles. And, in addition to the personification of cancer as sort of the enemy, he calls the wards the battleground. And, the war on cancer was a perfect transference from research and science being used for war effort. So they made a war on cancer also in order to be a fundraising element.
Mm-hmm.
But really it occurred to me that he was very empathetic person, it seemed to me, but if he called the wards of the hospitals the battlegrounds, I really think, and of course the doctors are the generals and the soldiers and that kind of thing, really the battlegrounds for this fight are the patients' bodies. They're the ones where the fight is taking place, and they are, the battleground is torn up and just devastated by some treatments. Some of these treatments were so debilitating, and not just surgeries, but the chemotherapy. You practically die and then hope you could come out of it afterwards. Some of the ones that he writes about are like that. So I think he's a very empathetic person, and the goal is his eye is on trying to cure cancer, to end suffering. But I really feel for the patients that would go through these experimental treatments and suffer the effects of some of these really strong drugs or these very radical surgeries.
Yeah, he gives an example of like two twin sisters. They both get a cancer. One is untreated. One gets surgery and chemo for like 18 months. And then the one that's untreated, doesn't realize it, doesn't believe it, but lives on for like whatever, 6 years or something. And the one that is treated gets lived for like 8 years, but like 2 of the years are total hell.
Mm-hmm.
And you get the feeling of, I did it. And then the disappointment of like, oh, it's back.
Yeah. Yeah.
You're like, now you're like questioning everything. And then she, she didn't make it anyway.
Yeah.
So it's like, well, what are we doing? If we're just literally trying to, you lived longer,
mm-hmm.
but you didn't live for like 2 years as you're while being treated.
Right. Yeah. All these studies and experiments with this battery of drugs to sort of try to eradicate this cancer. And then at the end of one trial or the next trial or the third trial, extended patients' lives by 2 months or something like that. It was really devastating and what they call a Palic victory, so maybe they learned a little bit, but they didn't really enhance anybody's life. And that's, again, feeling that the patients themselves were the actual battleground in this battle. It's really tough.
Yeah, it's like, it is too crazy to even like comprehend.
Yeah,
it is. Yeah, there's those two halves. We got the cure, because, well, okay, what do you mean cure? Something is bad for you now, like I can't eat, or my stomach is something wrong. Well, you got stomach cancer, so if you can't eat, that's going to be hell anyway, so you might as well treat it. Or other ones that are whatever, you got a tumor in your brain, but it's not really doing anything. It's not pressing into anything, so we'll just leave it there. So that's one whole half. It's like, what do we do about it? Which is maybe do nothing. And then another half is, where does it come from?
Mm-hmm.
So that binary is like, like incomprehensible, where, the history part of it, where they're all, he just explains how both sides were just fumbling through it and so sure, as bodies were just racking up, the body counts going up. And like, no, this is it. This has to be it.
Mm-hmm.
I mean, come on. That's the whole thing of these doctors. It's like, come on.
Mm-hmm.
I mean, come on.
Yeah.
And every time the hands up, like, come on, right? And it's like, no, still no,
wrong again. Yeah. It's pretty. Hopefully, I have to say that he tries to end on rather optimistic note, and that is that if they, they tried all these other things, then they had to go back to the cell, back to the cancer cell, and they have to understand how the cancer cell works, what causes the cancer cell to formulate, so that they can create what he called targeted drugs, so that it would attack only what they wanted it to attack, the cancerous cells, or the the mechanism that stops the break from functioning, or stops the cell from reproducing uncontrollably. So they have to go back to the drawing board again and try to do some really cellular research to figure this out. And every president, it seems to me, has including Biden, has said something about, we want to cure cancer in our time. Every single one. And it's just, it's just the slogging through this long battle.
Yeah, that is the thing. The cell, like he writes, a bacteria in your body is like an alien walking around in your house. Your body's like, what the hell is that? That is not a human. That's something from like the dinosaur's age, or mutated from my camel that I had to use yesterday. So then it'll try to kill it before it attaches to too many normal cells. But a cancer, the thing is that they recognize each other is by the surface. The surface of it has all these proteins and gateways sticking out of it. That's how they attach and go, okay, yep, oh, you got this, I need that. And then they do their interaction and they carry on with their careers as cells. But the problem thing is inside the cell, in that nucleus, which inside of a cell with all the different micro things floating around, the little micro employees of a cell can't get into the nucleus. Like they're like, you got to stay out, everybody out, only one. And even the way they do it is that the DNA is inside and we send out an mRNA, like a messenger version of us, and that goes out. So we got to keep everything safe in here. So it's like, yeah, your cancer cells, they look totally normal on the outside. And then the thing that's bad is on the inside, that even its own cell inside the cell, like, yeah, I can't even get in there. So someone knocks on your door, like, we got to get in there. It's like, dude, I don't know. I can't go in there either. So I don't know how you're going to get in there. And then so in the Gene book, his next book, he talks about how there's going to be coming, or what's happening already, is this CRISPR DNA repair, where you actually use a virus that can penetrate in, and then you actually, once you identify where the error is in the DNA, all the code, which is like infinitely long, you send this reprogrammed virus in there, and it starts just infecting with the correct DNA, and that's how you repair it.
Oh my God! It's so small. It's the cellular dynamics sort of. It's just mind-boggling to try and even wrap my brain around that kind of stuff. It's pretty, it's just pretty mind-boggling.
Yeah, it's crazy how even he talks a little bit, I think, about Genentech, which is totally a legendary company, which should be like, if Silicon Valley is a thing, which should all just be Genentech. Should be like whatever the Washington Monument of it, because they tackled synthesizing insulin for diabetic people, which is a hormone, and that is a protein, but a hormone is like a messenger protein, which helps to regulate the response to I guess sugar in your blood, and if you don't have that, then you can have too much, and then you go it's not good. So I guess Genentech, I think if I'm remembering it, they synthesized it. We can just make it and then give it to you, and it'll help regulate. Which is, that whole behavior of proteins are sent out, they attach to the cell surface, give the signal of this should happen, or not. And it's a whole... I'm coming to the word, he writes this word cascades and chemical pathways, where a cascade is like a chain reaction of events where, and it also goes down to geometry, because a protein is a random bunch of molecules together. And so let's say you have a protein, it's just, they're all chained together, a bunch of molecules, but each element or atom or whatever has a polarity where a negative end of this joint wants to get pulled into the positive end of this joint, like they're attracted. So a protein folds into itself into this crinkled up shape, this random crazy shape, and that shape perfectly fits into the receptor on the surface of a cell. And so that's where they synthesized it. They said, well, your body makes it naturally, but we found the perfect crinkle, the perfect folding of this super complicated protein, and now here you go.
Yeah.
And that science was so like infinitely difficult that even they laughed at Genentech. Like, what are you, crazy? Like, insulin is so complex, you're never gonna randomly make it. And they did.
And they did. Yeah.
That's our friend Carl Glaub's mom.
Yep.
Worked is there. So I wonder what she has a legendary stories there. Maybe.
Well, she was the CFO, I think.
No. Is that right?
So you're not a scientist.
What?
Yeah, I think so.
My God.
I'm not sure if she was the CFO, but she was on the financial aspect.
Oh, okay.
Not a scientist. But it's so tiny and so miraculous that what happens, that first of all, that they could even observe it, and that they could then substitute or influence it. It's just astonishing to me that scientists can do that.
Yep. Yeah. Like, yeah. And so, what was I just thinking? Like, what was I just thinking about? I lost it.
Okay. It'll come back. I thought that also.
Oh wait, I got it. I remember.
Oh, see, I knew it would come back.
Yeah,
okay,
this is another thing. Yeah, we talk about gene, throwing on words like DNA is the material that holds the information, and then a gene is, I think, like a segment of it that has a particular understandable thing, like hair color or eye color or something like that. But we can't see that. We can't see DNA. I think we can't even see genes or whatever. We know they're there. And then a chromosome is enough genes clumped together. And I think that's we can actually see in a microscope. Like, oh, that's a chromosome. Like whatever, millions or thousands of these genes like clumped together. And that, humans have a certain number of chromosomes, and like animals have another number. And if you have too many or something, it's a genetic disorder. So like, and all that stuff is in the nucleus of the cell. And so how do you get into the nucleus, into the cell, into the nucleus, into the chromosome, into the gene, into the DNA, and fix like one little thing?
Right.
It's like impossibly incomprehensible to even.
Yeah, it is. It's just beyond my imagination, for sure. And God bless him for, and they're again and again, the scientists that he depicts here are, he's working away in his basement lab. He had thousands and thousands and thousands of samples of, cancer cells. And it's just, they just keep doing the work. They do the work. And then maybe in the future, they'll discover, somebody will think of this idea, and then, oh yeah, this scientist over here in Massachusetts has got thousands of samples, and it'll work. They have faith in the science, and so we have to have faith in them.
Yeah, it's. I think I've seen also that's where they think these AI and supercomputing can speed up so much genetic and synthesis stuff, because as we randomly position those proteins, maybe this will work. Nope. Maybe this. Nope. Maybe this. Nope. Like an AI can do it like 1,000,000 times faster. And in it, and while we're sleeping, like I think this one might work if you make it. Try this.
Oh, okay. Huh.
Because in the past it's like one guy squeezing little droplets into whatever, waiting 6 months. Does that work? I don't know. Oh wait, we left the air conditioning on. Oh, this is all screwed.
Yeah, that's right. That's right. Too much human possibility for human error and too much susceptibility to chance. He spends a lot of time on the fundraising aspect of cancer. And this is one of the few areas where a woman was involved. And it was this Dr. Faber and connected to little Jimmy being the, not mascot, but, the patient who was symbolizing cancer research and cancer treatment and cancer cures. And this woman socialite, he spent so much time on that. And I was just really surprised that with all these chapters on science, there was a large section devoted to the necessity and the success and the potential for fundraising.
Yeah, I think, like everything. You got to raise money to do it. Also, like, well, we're collecting like $5 here and there. We need government to like get in on this. Is why government exists, to like intervene on things for the social good. And then, then, well, how do we do that? Well, I need to pay someone or get someone who can access them. So again, it's another link in the chain. Like, I'm the expert. I know something. I need money. I need money from government. I need someone who can get in the government to then give me it. So it's all this. It's another cascading thing, just like the surface of a cell, where this protein needs this protein, then that triggers this triggers that, this triggers that, into a final result of like an actual national cancer institute.
But only if you get somebody who cares. And all of this is based on the necessity for it all to be personal. And so this is where the egos come in. It's personal. Or this is where the fundraising woman whose husband gets colon cancer, she's remotivated and re-energized to try and find a cure. It's always personal. And whether it's their personal reputation or care for their loved one or care for their patients, there has to be some kind of personal motivation to either get politicians to listen or get people to give money or get somebody interested in studying something. It's very, that's the human aspect of this. So maybe AI will change that, because that you don't need the personal motivation for that to happen.
Yeah, it's also funny how they, at the time they're campaigning against like cigarettes definitely causes cancer. I mean, we don't really know that, but it probably does. I mean, come on. And then tobacco companies like, we'll pay you whatever $50 million to like not do that and just join us or something. Like all that economic and politics of it. It's kind of like if you're saying like Facebook causes whatever cancer, and then Zuckerberg himself is like, I'll pay you $1 billion if you do that, or you massage it a little bit, and you don't even really know if this is true. You just kind of think it is.
I don't think you even need the big guns to sort of massage it. I think one of the aspects of the human condition is denial, and so if you saw that movie Look Up, about, these scientists go on every TV show they can think of. They talk to the president. They talk to everybody. This asteroid is going to come and hit the Earth, and they don't believe it. They just, is this a priority? Do you have to think about this? And people continued to smoke, even with the warnings, even with there was statistical evidence and proof that cigarettes did cause cancer. And he goes through that in the book, where you see a statistical, while cancer rates had been declining when cigarettes were introduced, like World War II era, then then they went back up again and stayed up. And now they're declining again because more people are quitting smoking. But it's interesting that part of the sequence of feelings kind of that you're predicted to go through when you have a serious illness, step one is shock, I suppose, and step two is denial. And denial is a big part of this too, unless it's personal.
Yeah, that's one case of smoking is where you're damaging the cells, and as it repairs itself, did the smoke mutate a good cell's DNA?
Cause the mutation, yeah.
Or did, as you're hyper repairing, you're triggering, like, well, we need more lung. We don't know why, but lung is missing, so we have to make more. And as it makes more, one is defective and has its own spontaneous mutation, and now you have lung cancer. Like, is it the smoke, or is it the hyper repairing, which then ran?
I don't remember this hyper repairing at all. I just remember
you said people with stomach ulcers, as the stomach has inflammation, and it's like, oh, I'm fighting, my stomach is bad, and then you develop stomach cancer because you are, let's say, you're supposed to develop X number of cells in a normal lifespan, but if you have inflammation, you're now making 4 lifetimes of stomach cells within a shorter time, and then the chance goes up that one of those faster than normal created stomach cells will have the mutation randomly of too many or too quickly, or relocate, or immortal.
Mm-hmm.
That reminded me of a thing where, like, I read a Malcolm Gladwell book and thought he was like, this is smart. This is what smart people think about. And he was some chapter in a book was like, if you are constantly pregnant, like in a poor country or back in time, women are having babies like nonstop. That means the rupturing of the ovary to release the cell is not happening. So, like, ovarian cancer was down because the releasing of the egg needed repair or something. And so that's why, birth control, people aren't being pregnant, ovarian cancer goes up. And it was like, I remember thinking, oh, that sounds pretty smart. But now I've read this book, I'm like, that seems kind of, I don't know, flimsy. This was this, maybe.
Well, it's assigning cause that may not be. I don't know about the rupturing of the ovary to release the egg not happening, but definitely the hormone. I think the current thought is the shifting hormone levels. The more shifting you have, actually, the worse it is for you. So the more time you spend pregnant, the better it is for you, at least in terms of breast cancer. So there is something to that, but. And Malcolm Gladwell explores kind of interesting things, but this guy is a doctor and a specialist and an oncologist, and I think I would listen to him first.
Yeah,
maybe.
He also talks about, like, the whole boom of, like, testing, like, does testing even help? Mammograms. We did statistics on, does that compel women to get tested more? Does that result in earlier? Does promoting testing actually catch more early breast cancer? And does catching it early do anything? It does it. And it's so, again, multiple factors into different testing groups across, like, decades. It was like, even that is, like, incomprehensible to understand.
It takes so long. It takes so long to get any kind of definitive result. So you have to have, do these XY, does this X preventative measure work? Does it lead to longer life, which is all they want, really? Not a cure, but does it lead to longer life. And so they have to do the study for years and see if it actually does. If early intervention or if widespread testing, is it effective preventative? And should it be every year or should it be every 2 years? And all of those different kinds of variables go into those statistics. Yeah, so that's a kind of an interesting thing, because when he looks at the future, there are certain aspects of the future as regarding cancer that they have to consider, and one is treatment. One is about prevention. Analyzing the cause and finding, eliminating the causes, but also preventing the situations which can lead to it. And also
something about a drug called Gleevec that was really successful. But yeah, still, it's just the disease is like it's probably as old as time, but there's 4,000 years is the oldest version. I guess we actually have the bone of the fossil, maybe, I don't know the fossil, but the old bone with the bone cancer. But another thing he talks about is the whole the activism aspect of it, where people in the 80s, people were fighting for government support or recognition of AIDS research is necessary, and people are dying left and right, and we need to, these stingy doctors and researchers are waiting too long. There's bodies everywhere. We need to hurry up with it. And that was like, that urgency was good. But that is a virus, immunovirus or something. I forget what it is, but AIDS is the syndrome where your autoimmune deficiency syndrome, you don't have enough white blood cells, so you can't fight an infection. So something, a bacteria, or you can get killed from that. But cancer is just totally different. Like, it's just not. They saw it as the same. They said, no, we need these stingy doctors. They're hiding their cancer research when I could be cured by it. I heard it can help me, so give me it. And it was similar to today, where people think they heard something from someone, so I need that now. I need that. What the hell is
ivermectin?
Oh yeah, give me that
COVID.
ivermectin. Mm-hmm. I need anticolonal. Give me that now. Yeah. I need whatever you got.
Right.
And it's just like, and that's where government. Yeah, like no. Okay, no. We're the parents. You're the children. You don't just get what you want because you read something. And no, you're not just gonna get that, because the blowback is just, it can set it back like decades.
It can, if the inmates are allowed to be in control of the asylum. Yeah. But the AIDS activists, ACT UP activists, they did do something good. They did give a kick in the pants to some of these fossilized, institutions, and did force them to work faster and harder, and also did force them to open their doors a little bit and tell people what is available. I think, that led to Big Pharma probably doing advertising, ask your doctor if this drug is right for you. And I'm theoretically against that. Nevertheless, having a populace who are the ones that are the battlegrounds, in my opinion, are the ones that are suffering, having them be more educated and more in the know of what is possible and what's potential and what's in the pipeline is maybe not such a bad thing. It's, the little ivory tower thing has got to go away.
Yeah, that's another point where, it's totally case by case. You just have to have, that's why this guy is such a national hero. And like when, there's articles or videos about like, China has they have as many engineers and scientists graduating as we have. They have as many scientists graduating as we have all graduates. So and it's like, I'm not worried about it, because in that style, it's just nope. It's from all aspects. Like, I'm the boss, you all do this. It's all top down. There's no like arguing. There's no protesting. So no matter what, just like the American way is better, even though we screw up like relentlessly.
Yeah, I think the science in America is probably, well, people come here to study the science, so I think that it's more innovative probably, and more, maybe they're not as financially supported by government, but still I think that breakthroughs happen here probably.
Yeah, over there, if you have an authoritarian style, it's like, well, we need to cure cancer, and you need to do that by like Wednesday. And like, well, okay, well, we got 50,000 scientists, and they're going to do that. They're going to rush out some drug, because if I don't do it, I get thrown in the in the gulag or something. And then, oh yeah, there it is. Then we just test it out, and it'll explode later or blow back in our faces.
Yeah, we'll see. Yeah, well, we'll find out. We just had something similar here with COVID vaccine, and they did come out with a vaccine awfully fast. I mean, that was why there was part of the reason why there was reluctance to take it, but it is doable. It shouldn't be a leisurely endeavor, and I don't think it is. And I think that patients demanding is not necessarily a bad thing. Some pressure on the other side is not necessarily a bad thing, as long as it doesn't take over, and the inmates are not running the asylum.
Yeah, my friends in Thailand, they said it was super hard to get any American vaccines, and that the Thai government is pressing Sinovac, which is the Chinese vaccine, which had like effective rates of like whatever 60% maybe. And so it was, and people saying like, oh, well, the Thai government brokered, we'll buy yours, you kick back to us some money.
Yeah,
we'll get our people to do it. And so you're just like sowing mistrust in your own government and China, because China rushed something, because we have to do something with versus America. So yeah, when it comes to science, like, yeah, I'm not worried about that at all.
Well, I have faith that it'll surface eventually, and I don't think anybody's withholding anything necessarily. I think they're just slow. If they're slow and they're careful, but they could get a little nudge here to be a little bit faster. So I found what I was trying to articulate a minute ago about the future. And so there are still really lots of avenues to go for research and exploration and in cancer. So what he talks about is prevention. First of all, that's one big arm, and that can be attained by discovering what are the carcinogens, what are the chemicals out there that we are exposed to that may be causing cancer, and then of course also early screening, or regular screening to sort of detect things early. There are also therapeutics, and therapeutics under that falls both categories of surgery and chemotherapy. I think they're both considered therapeutics. And then the third branch is behaviors. So that is the behaviors of the cancer cells, of the cancer genes, the behaviors of the cancer genes. That is looking at these issues of mobility and immortality that occur within the cancer, and how they can create targeted drugs to stop those fatal activities of the cancer in the future. So I think there's some hope, but it's definitely not, cure in our time or anything like that. It's just so complicated. It is so complicated and multifaceted, and the understanding is having a hard time keeping up with it.
I think that it is in our time. Like, I think it's soon. Like even the corona mRNA vaccine was usually a vaccine. Is you culture the virus itself in a monkey, and then you extract it, and you kind of weaken it. You kind of like you'd make it sleep or dormant, or you weaken it and it's alive, and then you give it to someone. So yeah, here it is. Here's a light version, and then you fight it, and then when another version comes along, you're like, oh, I know this, and you'll catch it early. But the mRNA vaccine was like, it's shot into your cell, and that is genetic instructions for a cell to make a certain spike protein. Yeah, the protein that attaches to the surface of a cell, and your defense cells see it. Like, what the hell is this? This is like an alien in my house, and they kill it. And then now we know this spike shape, this crinkle, this protein. This is a weird design. We don't know this, and we need to get this out of here. And so that's why they thought it was like the mRNA vaccine is going to change your DNA.
Mm-hmm.
Like, no, that mRNA comes out of the nucleus into the housing of the cell, and then it makes something. And yeah, this type is one that is, goes into your cell. It's manufactured by a whatever, and it sits on the surface, waving a flag like, I'm an alien. Somebody take care of me. And then when the real coronavirus comes in, it has that same outer protein. So that, I think, yeah, that's you're introducing, that's why it was scary. You're introducing foreign genetic material, not DNA, not a retrovirus that will change your native DNA, but something that will say, here, make this. And then once you see it's foreign, your body will be like, get that out of here.
Mm-hmm.
From now on.
Until the virus mutates. Because mutation is inevitable. That's the problem.
Yeah, that's the thing too. So it'll change, and do we need vaccines every year? I don't know.
Yeah.
Because some viruses don't mutate, I guess. Like, does chickenpox nope, it's one type. And once you get it,
oh, I don't know that. I don't know the answer to that.
Yeah, like what is that about? So yeah, why is it only once and you don't need it? That's it. You're done. Like getting it is the vaccine. So there's just everything mutates differently, and it's crazy.
It is crazy, and it's just a huge emperor of maladies. It's just the emperor of maladies, and it just it just puts in the shade everything else that's involved, and everything else that's involved in human existence.
Yeah.
It's so big. It's too big to comprehend. Thank God we have him. This guy is just, I can't say enough how...
that would be, if you could just go, if he's around, he's like, I'm doing a talk at UCSF, and you could just shake his hand, or that'd be pretty mind-blowing. That'd be like, I don't know, what would be same if I could meet like Elton John or something. Like, wow, you have done
same superstardom.
What you have done.
I'm glad to be finished with it, however, because it is a little daunting, and one of the tasks that I had to deal with early on was he calls it a genetic disease. And when I say genetic, I think hereditary, but really what he is talking about is it's a cancer of the genes, not one that's necessarily hereditary. Although that's another aspect of cancer, that there are DNA markers that, make cancer be common in families.
Yeah, heredity is genetic, but genetic is not necessarily hereditary.
Yeah.
Because if you get a cancer, that DNA, that mutated DNA is in your body, but you won't
necessarily
I don't
pass.
think
You don't pass
that on.
Right. It's not hereditary. Yeah. Yeah. So it's a huge subject. And I'm amazed that they're still treating it, and they're still having this gigantic tent or this big umbrella, and all of those diseases are underneath cancer. It's just that they all share that characteristic of unbridled growth. And so from skin cancer to leukemia, it's all similar in that aspect, but there's no single treatment, cause, or cure.
Yeah. Alls I know is I'm not going to get it. I mean, come on.
The doctors.
Also, I used to think mutants were cool. I mean, X-Men, Ninja Turtles. I want to be a mutant.
Yeah.
Now Now mutants, not so cool.
Not so cool. No thanks. Don't want it. Take it away. All in all, good book. I'm glad I read it. I'm glad I've recommended it to people if they want something, serious and heavyweight to read. So thanks for suggesting it.
Yep. This guy, Siddhartha or Jared Diamond. Yeah, they're like, whatever. I don't know. The real historians who are, I don't know, really.
I just had somebody disparage Jared Diamond the other day, saying that he's all theory and no evidence.
Oh, what does he even know?
Oh, yeah, okay.
Oh, yeah, you say farming happened 11,000 years ago. Where's your evidence? What are you talking about?
Anyway, you have a book for the next time picked out, or do you want?
Oh, no, that's your turn. The Ministry for the Future. What is that?
It's it's fiction, but it's fiction, not fiction, and it's about climate change.
Oh,
it's the best. So it's called the best science fiction nonfiction novel I've ever read.
What the hell
is the story? And this guy has written a lot of books, futuristic, and this somebody gave it to me because she said it was hopeful about climate change at the end.
Yeah, I think it's good.
Okay, so this is the next one.
Alrighty, The Ministry for the Future. I will get it and read it.
By Kim Stanley Robinson. Mm-hmm. And it's another big, huge tome. I don't know why we're choosing all these giant books.
Well, playtime is over. Time to put on your helmet and do some work for once. So enough candy. Time for some vegetable.
Okay.
And
all right.
With that, that's one book down. We'll catch you next time on, what is this? Book Pod?
You've changed the name every time. Yeah, Book Pod.
On Book Pod. See you next time.
See you next time.